أعوذ بالله من الشيطان الرجيم بسم الله الرحمن الرحيم السلام عليكم ورحمة الله وبركاته. Good morning. Salam sejahtera to everyone. Syukur Alhamdulillah we can meet again today. Could you hear me, class? Anyone? Could you please respond?
Good morning, Doctor.
Yes, thank you everyone. Thank you to everyone. And Syukur Alhamdulillah we can meet again on the 20th of December 2021. 15 Jamadil Awal 1443. Our class is at 10. Today is Monday, 10 to 11, 1 hour class. So we are going to continue the lecture, perhaps with the last work example. So I'm going to change the slide. So I'm going to stop the slide here. So I'm going to give you another slide. This one, stop sharing of this one. This one is the other class. Okay, we are going to do this one, question number 3. You have this one in your notes, and also we will try to solve as here. So if you look at very carefully, the difference between these two topics, the difference between these two example. So if you look at very careful, you will found that, let me on my, you found that, remember I did mention earlier, this one is not given, it's unknown, isn't it? So as you have this one unknown, this one is unknown. So what you have to understand is the T mean must be given. So you look at the equation, they provide you T mean. Otherwise, you cannot solve. That is how to check whether your equation is correct or not. It doesn't matter this T belong to Y or X, doesn't matter, as long as the unknown parameter in the graph. The other graph, this one is very recent, 2020 semester, second semester. This one quite long time, yeah. This one on the about 8 or 7 years ago, yeah. If you look at this one now, you look at very careful. This one, everyone is given fine, isn't it? This one also given. The X and Y are given complete, isn't it? So you need to define T mean. This one you have to calculate T mean. So this is how you check whether equation that provide to you correct or not, or perhaps lack of information, or can be solved. So let us now start with this one. I'm going to start with this one first. I have no reason why I start this one. Yeah, just I would like to start with this one. I don't have any solution. I'm going to use knowledge that we discussed in class to help me out in calculating the numbers. So I also provide, I did have this one here. So this is your, this one is, yes. Then this one is the equation. So this one will be the working. Okay, now here, what you have is a shaft of electric motor, a shaft of electric motor. So provide also the type of application. This is electric motor. And rolling machine, you have a rolling machine are coupled together, and flywheel is connected on the common shaft. So we have common shaft, we connected via the flywheel, of course, through the what do you call it, coupling, universal coupling. The top requirement of the rolling machine is shown. This one is from the machine, from this machine. And it is found that the total mass moment of inertia, rotating part, and the motor and machine is 100. I remember this one is I system. So this I system is equal to I, the rotating part, plus the I flywheel. And they also provide you then 100. This one is for the rotating part. It's not for the system. This is the rotating part. It's only 100 kilogram meter per square. The motor drive a flywheel, a constant torque. They provide the constant torque, as I mentioned earlier. You have the inadequate parameter, so they provide you here. This one be 70 Newton meter. And the maximum and minimum speed of the shaft given here, 505 and 495. To define will be the alpha. Remember, the alpha is the coefficient of fluctuation of speeds. So determine the following: number of product producers of the machine in 1 hour. Remember, 1 hour. So you have n is equal to 3,600 divided by time for one period. Sorry, it's not one period, for one cycle. The other one is what will be the magnitude of t. We need this one. Then only the mass moment initial of the flywheel. This one, the I flywheel, because then only you know what will be the I system. Okay, then if the radius, what will be the radius of flywheel to be fitted to the system if the materials density given by 8,500 kilogram meter cubes, and the ratio of radius of thickness is ratio of radius to thickness is equal to 4. So the radius is basically 4 times of the thickness. This one, yeah. So these are the points that you have to understand before you move on or start to solve the problem. So now let us now do together. So the total number of product producers in the machine in 1 hour. So now we go back here. So we're going to look for n. We're going to look for n. N is equal to 3,600 divided by t. We do not know what will be t. T, this one must be in one cycle. Okay, so what you have, this one is so many cycles, isn't it? So you have to read the equation, or you have to read the graph to define where will be the one cycle stop. So could anyone tell me where there will be one cycle stop? So there I put here n equal to 360 divided by. So tell me where will be the 14. Thank you. Yeah, this one 14. So you will end up here one cycle. So you have this one by 14. So what do you get for 360 by 14? What do you have? You have could anyone? You have numbers here. Thank you. You have 257.14. Remember, your n is actually 257. Number one, complete. Number one, answered. Number two, what is the equation for number two? Talking about what will be the magnitude of the torque. This one, T, the magnitude of the torque. Okay, so we end up at here for one cycle. So this one is belong for one cycle. Put it there, one cycle. One cycle. So to define, to define anything regarding the graph here, because this is the turning moment diagram graph. The turning moment diagram is basically what? Concern about energy conservation. So from, put it there, from what? T theta. You have motor just now. Motor equal to T theta by the machine, which is rolling machine. So you found that this motor will be contribute a constant torque. Will be contribute the constant torque. So, and we do not know what be the constant torque yet at the moment. So what we do know here is you have this one. You also have this one. Then you can calculate this one. So if you calculate this one, for example, you have, okay, this one we have half multiplied by 2, the small portion of triangle multiplied by 200 by omega. Remember this one multiplied by, because you have to convert this one, theta equal to omega by t. So you have to multiply everything by omega. Plus, you move on. This one is 200, is a 200 by 5 omega. Then you move on, minus by, this one is 14 by 9 is 14 by 9 is 1. 14 by 9 is 5, isn't it? So you have t, you have t, this one 5 omega. Equal to t equal to will be, you already provide us this one, this t mean. So I'm putting a t mean as cross the line. And this t mean is equal to, what is the t mean just now? 70, yes, 70, equal to 70. So then you have to work out this one. Okay, this is the area for the inputs. So the area for the input for one cycle, you will have 70, isn't it? 70 multiplied by what? multiply by oh, sorry class, sorry, it's not 70, sorry. 70 is correct, sorry. 70 multiply by 14 omega. So you end up this one by t. Could anyone give me what your t is? What is the value for t here? Anyone? A very good, 44. Thank you. 44. Yeah, it is negative 44 Newton meter. So you have here negative 44. Thank you. Done, yeah. So now you can, you answering basically second part of the equation, which define you t will be 40, negative 44. Doesn't matter negative, this because this negative is not basically belong to the integers. Are talking about the system, have the negative, or what we call it, the negative work done. Huh? Okay, the other part is the next question is mass moment of inertia of the flywheel to be fitted. Okay, now we are going to look for the mass moment inertia of the flywheel to be fitted. So we move to number 3. Remember the equation? We have beta E is equal to I alpha omega mean power of 2 is equal to E max. Remember, E mean. As I mentioned earlier, you cannot run away from the energy, and this one is coming from the energy. And if you can simplify this one, your I is equal to beta E divided by, you have the alpha omega mean power of 2. Correct? What is the alpha? The equation provide the alpha. So if you read the question very careful, the alpha is provided by the speed. This alpha is equal to, remember, the n max minus by n min divided by n. At the moment, you don't know what the n is, so you have to calculate the n min first. So put it in n, sorry, it's not omega, yeah? Put in n. N min is equal to the n max plus n min divided by divided by 2. So this will give you what is now 505 plus 495 divided by 2, which will give you 500. So your n min is 500 rp. Let's check, correct not? 505 495 correct. And this one is simply, simply give you the this one is a 505 minus by 495 divided by 500. So you will be getting here 5 by, sorry, this one by 10 by 500. So what we have, class? Could anyone give me what is the alpha here? Anyone? Yes, thank you. 0.02. So alpha calculated. So alpha calculated. This one also calculated. So the next point is basically the fluctuation of energy, maximum fluctuation of energy in one cycle, or perhaps in other words is E max minus by E min. So I'm going to draw another line. This one end up at 14. This one is just now is given by 70, and this is our T min. So now a new graph will be fluctuating above and T min. Above and below T min. So this is the below T min, above T min, the whole thing. This one be below. It's not very difficult, isn't it? So the next thing before you do anything, you have to look for the intersection point, which will give you this one, put it at A, this one put it at B, this one put it at C, this one now put it at D. Any question up to here? Any question? Any question, class? Thank you, Lee. Okay, now so now we are going to look for is the very important, yeah, in your calculation. You'll be getting the same result as I mentioned or I showed you earlier, but you'll be getting 0 mark from that, because it's a wrong concept typically when you are considering this one positive instead of negative. Yeah. So if I look at here, so help me out here in calculating the energy. We got quite a numbers here. So now let put it there. This is energy analysis. And we start with giving let A is equal to U. Let A equal to U. So B is equal to U. This one all negative. Sorry, all positive. Like you have this one. You have what? What do you have? This one, the what do you call it? The interpolation. Interpolation, isn't it? So you need to do something about it before you do the calculation. So how are you going to do the interpolation now? Anyone? Anyone? This one interpolation. This one to look for this one. Put it there just x. Put it there x. So x, let x divided by this one is 2 is equal to what? Is equal to 200 minus by 70 divided by 200. So you have x equal to, what do you have for x? What do you have for x? Anyone? I don't have calculator with me. So if you work out, very quick, so we can also do this one very quick, sir. Anyone? 1.3. Thank you. 1.3. Thank you. Yeah. So a small portion. This one is 1 point. We put it at 1.3. So this is from the 0 to 1.3. So you will have this one. Of course, you will have 1.3. You will have this one 2.7. Isn't it? So that makes us, easy to run through the solution. So you have this one. Okay, half multiplied by 2 plus 2.7 multiplied by 70, isn't it? Multiplied by 70 omega. Correct or not? So what do you have for that? Anyone? Check, yeah, whether my calculation is correct or not, yeah? So I don't, as I mentioned just now, I don't have calculator with me. I got calculator, but I don't know where do I put the calculator. So anyone? Could anyone tell me what do you have for that? Oh, it's 164.5. Okay, U plus 164.5. Omega, don't forget, yeah, you have omega. The reason is why, because you have here this one, theta is equal to omega t. So you have to multiply everything with omega. So we come back here, then you have the C here is equal to C will be here. So U plus 164.5 omega. This one is minus by, we have another one, another trapezium, which is now is 5. This one is 5 plus 5 plus a small portion that you calculated earlier by 1.3 multiplied by 200 minus by 70. So could anyone tell me what you have here? Just give me the results. And of course, we know the result at E becomes 0, at D becomes 0. So I need all the numbers here to help you out. Yeah. This will become part of your solution in helping you solving the problem typically on your tutorial. So could you please tell me what you have here? Anyone? Hello. $570. Thank you. You have U minus 570 omega. Oh, this one. Sorry, yeah, I forgot to multiply by the omega. So let us now go to the last point, U plus 570 omega. You know that in your mind that it's becoming 0, isn't it? So let's prove it, whether the energy been conserved or not. Minus by plus. This one, what you have is 70. This one is 44 just now. 44, isn't it? 44, yes, correct. Of course, we have negative 44 here. So 70 by 44 multiplied by 5. So what do you have there? You have 70 plus 44 multiplied by 5 omega. Correct. 5 omega. Yes, correct. So what do you have for that? Will it give you 0 or not? You 0. I presume it's 0. Okay, so this one is put it here. Energy is conserved. Energy is conserved. So it is not very difficult, yeah. If you basically run through the exercise, it is very easy because you know that where you go wrong. So the next point is picking up all the or selecting all the Emax and Emin. We start with positive. This one is 164 positive. The other one you don't have here, so this one be becoming our Emax. Become on the negative or below zeros, we have this one is Emin. This one is E. So finally, your beta E now is equal to Emax minus by Emin is equal to Emax will be U plus 164.5 minus by U minus by 570 omega. Oh, sorry, this is supposed to be omega here. You must put omega here. So that will give you, what do you have for that? What do you have for that? Anyone? Common class? If you don't want to help me, I just put it here. I put XXX. 734.5. Thank you. 734.5. So we can also prove whether it is correct or not, isn't it? Remember? So we can also prove whether it's correct or not by using what? Another alternative solution, calculating the Calculating the beta E. So can we use this shortcut way now? Can we use the shortcut way now or not? Yes. But why? Because you only one area overshooting to mean T-mean. So now beta E can also be calculated as half. Just this one is to double check, double check. DOUBLE, double check, correct or not, your calculation. So half multiplied by this one will be, you have 5 plus 1.3, you have 6.3 plus 5 multiplied by 130, not to forget the omega. So could anyone tell me is this correct or not as what you have earlier by 7345? 734.5 omega. Is correct or not? Correct. Thank you, Nazila. Thank you, Marcela. Okay, so it's not very difficult, isn't it? So when you counter check the numbers, or the value by a couple of alternative solutions, so you be getting the same result, inshallah. So this one is your first calculation result from the normal procedure of calculation. This one is your alternative. You can use this one when running out of time. Typically, you want to answer this one, and you know that this one is going to be your ACE topic in your test or exam. So the next thing is defining what mass moment of inertia. So beta I now put it the equation. Where is our I? Just now put it this one. So your I now, I is equal to beta E is calculated by 734.5, not to forget the omega, divided by, we have alpha 0.02. The next one is 2 pi, 2 pi what just now, multiplied by 500 divided by 60. And this one you have omega as power 2, right? So we can cancel this one, you can cancel this one, you can cancel this one. Correct? So you have now, could anyone tell me what you have here? Come on, what do you have here, class? I got with me, how many of you, John Michael, I got with me 45 engineer to be, inshallah. So what do you have for I now? Anyone? Tan, Lee? 701.4. Thank you. 701.4 kilogram meter square. So this is the equation. So the next thing is to define, the next one is to define what? We're going to look for this one calculated. But remember, as I mentioned earlier, whatever you calculated, this one is not for flywheel alone, correct or not? Yes or no? This is not for flywheel alone, isn't it? Yes or no? This is the I system. So your I flywheel or I system is equal to the I rotating part plus I flywheel. Or in other words, you have 701 by 4 is equal to the I rotating part given by I rotating part is, what is the I rotating part just now? The I rotating part is given by 100. This one, 100. You put it here is 100. Then give you plus the I flywheel. So this is the I flywheel now. So therefore, your I flywheel is basically 601.4 kilogram meter square. Understand? Is that clear? Is that clear? Anyone? Yes, go, yeah? Okay, now. So the next point of question is to define or perhaps to design the flywheel in such manner that the equation asks us to define what be the radius of the flywheel now. So we are focusing on flywheel now. So remember, number 4, I suppose. So parameter to design the flywheel, R and T, remember, isn't it? So we are going to look for from I, this one flywheel, yeah, flywheel is equal to half mr square. And we know well that this I flywheel is belong to this one. You put in the numbers here, 1.4 is equal to half mr square. And we expand the equation, we expand the parameter m, sorry, it's not the parameter of mr, yeah, only the parameter for m. We expand this one, expand the m. How is it? It's not very difficult, isn't it? Your m is equal to rho p. Rho is this density. And it can also be in the form of area by thickness. Or in other words, can also in the form of pi r square by t. Now, on the other hand, they also provide you what the you have here, r by 4, r by t equal to 4. You can put in a number r by t by 4 later on. So now we're going to focus this one. So half m will be this one is pi r square multiplied by t multiplied by r square. This one is 601 by 4. But they provide you r by t is equal to 4, right? I by t equal to 4, yes. So take this one, put it in the equation, put it in the equation. So what you have is 601 by 4 is equal to, you can put r, you can put t, doesn't matter, yeah. We should feel easy for you. You can put r is equal to 40, or you can also put as t is equal to r by 4. It's up to you. As long as the equation is correct when you manipulate or play around with the equation. So you have half, this one is 8500, this one is pi, then this r keep maintain r now, r power of 2, change the t now, t becoming r by 4, this one will be another r power of 2. So if I simplify this one, you'll be getting this one 1 by 8, this one 8500, this one is pi, this one is 1 pi. Correct? So now you can have your R phi is equal to, we have 601.4 multiplied by 8 divided by 8500 pi. Isn't it? Or can also have R equal to all the numbers here by 8 divided by 8 by 00 pi. So could anyone tell me what you have for R? Anyone? Anyone? No? It is not very difficult, isn't it? We have such a complex calculator, you can just punch it in, get the 1.5, 1 upon 5 power. 0.0.1801. This one in meter, or you can also put it here as 100, 1800, multiplied by 1000, isn't it? So be getting about this 1 millimeter radius. So I do this one about 25 minutes with your help. With your help. Your help in terms of what? In terms of giving the numbers. But if I focusing this one, I can also finish up at 10 minutes. 10 minutes time. I do alone, I focus on thing that calculate 10 minutes with correct, inshallah. Okay, typically if lecturer can do 10 minutes, student can do within 30 minutes, 3 times. It's not due to this lecturer is clever, no, it's due to what? Due to the nervousness system. Lecturer doing this one is not for the sake of attending test or exam, but in their lavish time. You are doing this one for the sake of, you are chasing time. So there is why multiply by 3 for the student efforts. Okay, this one it's not very difficult. Any question before we move to the next one? Any question? Any question? Nope. Okay, I'm going to move to the next one. Episode one here. Going to clearing this one. I got a couple of minutes. Inshallah, we can try to finish this one. Yeah. What you have here is, if you can read the equation, you have the relationship between torque and time. Torque and time, correct? Of a power source, and the question doesn't mention about what type of power source you have. Don't bother about that one. You know that this one coming from the power source. Now you tell me, if the power source it keep fluctuating, so the power source coming from what? Anyone? Anyone? Yes, from internal combustion engine or from engine, because the power source itself showing you on what? On inconsistent of torque, isn't it? So this one coming from internal combustion engine. So sometimes you have to read the equation to provide you another information related with the power source. Okay, which rotating with a mean speed of 600. Shown here, okay, fine. The maximum fluctuation of speed is limited by 10%. This is alpha is 0.01. Determine the following, the mean torque. This one because they provide you all numbers or all values. So you need to define what be T mean. Then of course when T mean it will lead to power. Then, as usual, mass moment inertia, because we are talking about the internal combustion engine. So the flywheel will be representing for the I system. Remember, as I mentioned in the class, yeah. So the next in the radius, so this one same as before, same as before. This one now is the actual thing. This one is put in the I system is equal to I flywheel. So when you understand the thing that you have here, then you can start solving the problem. So first is understand the problems. Okay, now I'm going to do this one. So I'm going to move here. So it was close here. So first I'm going to look for the T mean now. Okay, to find T mean, remember, to find T mean, so you have what? Energy use, energy conservation. How is it? Coming from the equation of T theta input is equal to T theta. We do not know, just put it output. This input coming from the graph. The output is constant. Okay, before we do the input here, you need to know for 1 cycle. So go back to the figure and now tell me where will be 1 cycle stop from 0 to 15 seconds. So it will stop at 10 seconds. Thank you. So it will stop at here. So this one will belong for 1 cycle. Then easy, right? So then this is the concern area under the curve for the inputs. So start calculating this one, and it's not very difficult. So So you have what? You have 30 by 2, isn't it? You have, okay, don't forget, yeah, this one in seconds, so you need to multiply by omega. So if I can do this one quickly, so what you have here is, you have, okay, negative 30 by 2 omega plus the top here is 120 by 5 by 2 is 3 omega. This one will be, don't worry about this one, there is no torque involved, but yet it's counted as one cycle. Sorry, it's counted as in a cycle operation. The next one is to move on. You have this triangle there, half. This one is 4 base, height will be 100, and not to forget multiplied by the omega is equal to, and we do not know this one, just put it at T min, and you just now see that it will end up at 10, so put it here, 10 omega. Right? This one you have what? You have 60 negative 60 omega. This one be 360 omega. This one be 2. You will have 200 omega. You have this one T min 10 omega. So if my calculation is correct, you have 500. This one 500 omega equal to T min is equal to 10 omega. So your T min is equal to 50 Newton. Correct or not? You can use, you can solve this one using calculator. Yes or no? Okay, then you know that this one, then you go back to the figure, you go to the figure, then you start what? Start construct the line. So the line will be cross over, but all single graph. This one before at 50. Then you have a new graph. Then you will have a new graph. So we basically answering the first part of the equation, T min, then power. Of course, you need to look for power, yeah, because the question asks you to look power. So power is equal to T min omega min is equal to 50 by 2 pi. Speed, the mean speed provided here is, what is the mean speed just now? 600 by 60. So you will have here, this one is 10, correct? Then you have this one is 50 by 20 pi is equal to 1000 pi. Am I correct or not? Yes or no? Excellent. Then in what? Huh? Okay, now the second one is to define what just now? To define the mass moment of inertia. Again, equation being used is this one. Of course, we have to start the equation from the very beginning. Yeah, I'm going to pick up the equation that we done earlier. So we have the beta E. This one is the alpha omega min power of 2 and equal to E max and E min. Look at here. So you cannot run away from doing the energy analysis. And the energy analysis is the heart of the solution. So if I can go back to here, then I cross this graph and I will end up at 5 as 10 here. So this one belongs to one cycle. So my new line will be, my new graph will be this one, the whole lot below T min. This is T min now. And T min fall at 50 just now. We calculated T min. Then you have this one is below, above T min, below T min, and this one be above T min. So this is the new line, the new graph of the energy fluctuating of the system. Then what you do is the same procedure, saying that, okay, now I'm going to put the notation here as A, this one B, this one be C, this one be D, this one is D. As you have the, what do you call it, the slanting line, you need to perform the DE zone. Put it there, DE is equal to this one, yeah, DE divided by, if my calculation is correct, by 4. You have this one 100 minus 50 divided by this one will be 100. So you have DE small portion, that one is equal to what? 200 by 2 equal to 2. Am I correct now? This one is the small portion, this one is 2. Yes or no? Don't just keep quiet and copy, you need to you know, you need to reply or you need to respond to me. Is that correct or not? Okay, so now, so the next one is energy analysis. How is it? Let energy at E is equal to U. Then energy, okay, before that, sorry, yeah. Before that, because we are dealing with the internal combustion engine, yeah. So the energy or perhaps the area above determined will consider as positive. Thank you, yeah. Thank you, positive. This one be negative, of course. Isn't it? You know the reason because we already completely theory in our meeting couple of days or weeks ago, yeah. So here now B now is equal to B will be fall below T means, so you have U minus by what do you have then? This one is 80 by 50 by 30 is 80 multiplied by this one is 2, but you have 80 omega. Sorry. It's not 80, 160. So basically 180 multiplied by 2 omega, becoming U minus by 160 omega. So now I have a couple of minutes before I finish up the whole thing. Yeah, so you have U minus by 160 omega, then you plus the top here is 120, this one 50, so 120 minus by 50 multiplied by this one 3 omega. So you will have a U minus by 160 omega. This one is 70, but it is plus 210 omega. This will bring you 1 minus 210 by 160 is 50 omega, isn't it? Then we move on to E now is equal to, you know that the small portion, this one is 2. So this one is 5 to 10 by 5. So this one become 3. Correct? Yes or no? Then you have U plus by 50 omega minus by that is the trapezium. So the trapezium will look like as 1 plus astaghfirullahaladzim, 1 plus the other part is 3, correct? Multiply by omega, multiply the height is 50. So this one becoming 200. So you will have here is equal to, check, yeah, whether my calculation is correct or not. You have U, this one is 50, this one is 100, so it becoming U minus 50 omega. Correct or not? The last one, yes, E. This one A, B, C. Oh, I missed one. Sorry, yeah, I missed one. 1 point. It is correct. The calculation is correct, but I miss here is supposed to be, this one is supposed to be C. This one is supposed to be D. Then I put the E here. My last line. I know that this one becomes 0, but I want to check. I want to prove it. U minus 50 omega. This one we have plus half. What do you have there? You have half. You have 2. This one is 2 omega multiplied by 50. Then this one settle. So you will have this one U plus 0, and it is proved that energy is conserved. So as you know that the calculation is correct, you can also double check, isn't it? By double check by using this shortcut way. So now I'm asking you whether can we use the shortcut way to calculate the beta E now? Cannot. Why cannot? Go. No, why Asha? Because 2 areas. Because you have 2 areas above T means, so no shortcut way now. Remember that, yeah? So now I'm going to select Emax and Emin. Put it positive first. Positive will be here is positive. This one, the pickup here is at maximum. The other one is negative, or perhaps 0 here, negative. This one is the highest one, is 160. This one is negative. Am I pick up the right one or not? So beta E now is equal to Emax minus by Emin. 3 more minutes is equal to Emax will be U plus 50 omega. This one is minus by Emin be U plus 160 omega. Right? And finally, you will have here is equal to 210 omega, Newton meter or joules. Then you already answer the mass moment inertia. We haven't put it in mass moment inertia, yeah. So therefore, your I now is equal to you have 210 omega divided by alpha is 0.01 just now. Your your omega mean, we already calculated omega mean just now. Have we calculated omega mean? No, no, we don't calculate omega mean yet at the moment. So we just put it here 2 pi by, what is the speed just now? The speed is 600. So you have 600 here divided by 60. But this one, the power of 2, cancel. So that will give you 110 divided by 0.01 multiplied by this one is 10. You have you will have 20 pi. Then check out this one, your results. 324. Okay, thank you. 334.32. Thank you. Yeah, those are contributed your effort to calculate. Thank you very much, for helping me. So the next thing is what? The next thing, as usual, that we done earlier. What is that? That is basically coming from the equation that I is equal to, now whatever you have I here, yeah, this is I system now, is equal to I flywheel, is equal to 334.32 kilogram meter square. Then you start calculating I is equal to half mr square, and your m as usual rho by a rho by v, rho by e by t. You open up, you expand the equation, become 5r square. This one is t. Then put it here again. Not to forget, this one is your I. Then you be getting out. Okay, so please complete this one as your become your exercise. You don't have to submit this one. I will inshallah give you the couple of set of past year tests to become your individual assignment. And I also provide you yesterday a couple of things in your what do you call it, in your projects, group projects. I think everyone clear about the group project. You can choose out of 10 title. You can choose anyone. It's a free selecting title. We are basically trying to give more room to students just to select which question that you like to solve. But please do not copy from your friend, because if you copy, you get nothing for that. It is not because of you want to mark. Beside mark, you also want a knowledge. Okay, not only marks. It is not carry so many marks. Only 5%. Okay, if you copy your friend, you are very wrong, because you are basically not gain any knowledge regarding the performing programming, for example. Do as a group effort, everyone will get five marks. Okay, I think that we come to end 10:30 now, 10:50. I know you have to attend another class. So any question, 1 minute before we complete our topic today. Inshallah, on Wednesday, we're going to move to the next topic, on vibration. Okay, I'm going to explain about thing vibration. So the important vibration, it is not in your test or in your term exam, but important in the content of the vibration. So with that, I end my session. Thank you, class, be with me. Thank you for those who are participating and calculating for me. Hope that you really enjoy my class. Hope that you understand the thing that we discussed here, all the material provided. So with that, I end my session with Assalamu alaikum warahmatullahi wabarakatuh. Meet again inshallah tomorrow. Stay healthy, stay stay safe, and also have a nice day. Thank you, class.